Hello everyone, I would like to present my topic in 2024 QFDAM Conference Paris. I am Zhenyun Zhuang, and another author of this study is Noureddin Koaisa, and you can also call me Wen. And today the topic is linking mathematical models with regression models. A short example from an empirical study on driving consumers' willingness to visit, conditioned by a more dual pricing policy. And this is the agenda of this presentation. We have 4 sections, and the first one is the background, the second one is introduction, and the third one is derivations, and the last one is discussions. And about the background of this study, the dual pricing problem was mentioned a decade ago. The problem involves deciding a so-called PS portfolio, and this includes deciding P and S at the same time. P means the per hour parking fee for visitors to park in the mall parking lot. S means the minimum spending in the mall for visitors to trade for 1 hour of free parking in any possible form. For example, you can have some discount coupons. From the first perspective in logistics, since logistics service that involves supply and demand may require pricing, a parking service requires pricing too, because it is also a logistics service. From the perspective of transportations, for public parking pricing, there are usually the WTP, which means willingness to pay, and WTA, which means willingness to accept concepts. However, for private parking pricing, for example, the most parking pricing problem, an important concept is usually not these two, but WTV, which means willingness to visit. From the second perspective in logistics, which is service logistics instead of logistics service, the parking service should be delivered to their customers on time and at a competitive price. This is why the dual pricing problems of malls are important and need to be addressed by the academy. Like these papers, the literature is abundant with studies which have discussed this type of parking service pricing. This means that this type of problem has been important now, among other problems related to parking of the retailers. So is the importance of the key WTV concept, that this type of problem has involved. The very first study about dual pricing problem was the one that constructed a mathematical model to decide the best dual pricing policy setting for a mall in Taiwan. The objective of the model was to maximize the total profit that can be earned from both the parking lot department and the mall marketplace department per potential driving visit, which means per capita. These two profit terms are called ECPC and EIPDV. The point was to decide the combination of P and S to maximize the per potential visit profit of the mall, which includes parking lot profit and the mall marketplace profit at the same time. The overall scheme of the model is shown in this figure. The driving visitors have their WTV to visit the mall. Their WTV affects the profit of mall marketplace linearly and affects the profit of parking lot non-linearly. So their WTV affects the per capita profit of the entire retail market. This further affects how the logistic manager of the mall decides the dual pricing portfolio that is to be set as a policy for the retail market. The decision model was an OR model. OR means operations research, or more formally, operational research. Yes, the decision model was an OR model which also formulated the monetary flows that happen inside the mall. More precisely, the mathematical decision model was formulated using GP, which means Go programming GP, which fell in the scope of multi-objective programming or multi-objective decision making, which means which is usually abbreviated as MODM. Recently, Zhuang and Zhong's study launched a survey to investigate an important part of the model, which is exactly the WTV function in the model. Their survey was also launched in Taiwan during the pandemic, and a lot of methods were used together to investigate the model parameters accurately. Several insights and implications were also gained. For example, it was found that the importance of P in relation to S, or in other words, Z star, which was perceived in visitors' mind, was approximately 4:1 in this area. The knowledge contributed to several fields like transportation pricing, consumer psychology, and operational management. However, an important link was lost in that study. The link between the model formulation of the WTV function in OR and the regression model that was established for polling was lost, and the regression model was then used like this or as is in all subsequent analysis and works. However, the basis of this regression model was questionable. How this statistical model was obtained and how it could be linked from the original WTV function, this question remains dangling. This study is to serve this purpose. Let's check back the formulations of WTV. First, we know that in fact consumer WTV also has two constituents, a part affected by a mall's pricing policy, which is W from PS, another that is conditioned by all other factors, which is B. In equation 1, they are C1 and C2. These two parts are combined using the weight A. All things are normalized and having values between 0 and 1. And perhaps this figure illustrates the relationships between W from PS and WPS. Suppose that there is no conditional change before or after a pricing decision. The relation between the part affected by the mall's dual pricing policy, which is WPS, and the total WTV, which is W from PS, is shown in the figure. And WPS, which is the part affected by the mall's dual pricing policy, can further be decomposed as equation 2. The story was the previous study jumped directly to equation 3 from equation 2, but the link for how equation 2 can be derived as equation 3 was missing. Obviously, equation 2 was the function in an OR decision model, and equation 3 was a statistical regression model to be established by survey data. However, the link was missing. Even the subsequent analysis or later studies conducted based on equation 3, like this equation 4, is persuasive. How equation 3 was obtained from equation 2 should be justified. A trial was like this. Know that for a mall and its consumer group, P bar, P underscore, S bar, and S underscore should be fixed constants because they represent a consumer's perception toward the lowest acceptable parking fee, the highest durable parking fee, the lowest acceptable parking discount threshold, and the highest durable parking discount threshold. They are all constants during formulation, and the decision modeling works because they need to be investigated actuarially. However, analyzing equation 5, we see that there are multiplicative terms of variables z, s, and t. Moreover, this equation is too complicated. Also, after an inspection, equation 5 does not lead to any chance to establish any regression model. Let's try another right derivation using the assumption that p underscore and s underscore are both 0. This assumption is reasonable because on an existing study by QFDAM and others in 2010, taking that assumption and derive from the definition of W prime PS once again with some efforts, the final form of equation 6 is exactly what was used as the MLR model. MLR means multilinear regression in the previous study. Even the relations among the variables P, S, and Z in this equation are not clear. One thing is very clear. It's clear that this formulation is very simple, and when it is rewritten like equation 7, it becomes a function of P and S, and clearly, equation 7 can become a regression model with W prime as the dependent variable and P and S are independent variables. Even the model is nonlinear. But what if the regression model can become linear by hiding Z temporarily? This should be the best policy, I think. So the previous paper used this method to hide Z temporarily and retrieve back the value of Z after other parameters in the model is estimated by using a simultaneous equation system, which means SAS. So, from this study, we understand that QFDAM's theory should have provided the clues to obtain the regression model in Zhuang and Zhong's study. It can thus be confirmed that the basis to derive the multiple linear regression model is grounded, which means MLR model. So it is also sound to take it and launch the survey. It can also be confirmed that the results obtained by the regression model, for example Z, can be fed back to the OR model to formulate WTV actuarially. Now, the link between the WTV function in the OR model and its substitute, which is the statistical MLR model, has become solid. And at last, through the above case, a link between a decision model in OR and the regression model in statistics is shown. Nothing is more important than this, because methodologically it underlies a solid foundation for other works in the future. It provides a good reference when any other work aims to link mathematical model formulations with a regression model. Or we can say more broadly, it paves the way to investigate something for a mathematical model through an empirical survey. So what we think this is the main contributions and discussions and conclusion of this study. And that's all. I am Zhengyun Zhuang from Department of Civil Engineering, National Kaohsiung University of Science and Technology. And my co-author, Noureddin Koaiza, is from Africa Business School in UM6P from Morocco. Thank you for your listening.